Welcome to lesson 4.1, Investigating Circles. So we're starting a new unit. In this unit, just like the title kind of implies, is circles and area. So we're going to be looking at the shapes of circles particularly, and parallelograms a little bit. And basically we're going to be looking at the different parts of the circle, learning how to measure circumference, learning how to measure and add angles of a circle. But for today, this lesson, the focus is just to measure the radius and the diameter, and firstly learning what the radius and diameter is in a circle, and just to discover their relationship towards one another. So we're just going to start by drawing a circle and looking at the different parts of a circle. So I'm not using a compass or anything, obviously, but there's my circle. We're going to imagine that it's actually a perfect circle. It looks a little more oval to me, but that's okay. And we're just going to start by drawing line segments that cross through the center of the circle. And again, mine might not be perfect because it's not necessarily a perfect circle. But if I was to draw line segments that cross right through the center, another way you could do that, imagine you had a piece of paper in your hand and you had a perfect circle, cut it out. If you fold that circle in half so that both sides are even at several different places, they would all have one point in common. And this point, where they all kind of overlapped or folded or creased, that's the center point of your circle. And basically what you want to notice about this is that all points on the circle, whether it's this line or this one over here, they're all the same distance from the center to the edge of your circle. So there's not any one line segment that's longer from the center. All points are equal no matter which line segment we're talking about. So I'm just going to go ahead here and draw one more circle. And again, we're going to imagine that that's a perfect circle. If I was to draw one line right through the middle, and again, we're going to imagine that that crosses that center point, which I can't draw very well. The line segment in any circle that passes through that center point that touches two ends of the circle is called your diameter. So I'm just going to do an arrow here. Oops, diameter. So your diameter is the line segment that cuts straight across the circle through the center point. The diameter passes through the center, and if we want to look at what the name of the line segment from just the center point to the edge of the circle is called, that's called the radius. And essentially, what I hope you notice is that the radius is 1/2 of the diameter, because we know that any length from the center point out, like we talked about here, is the same distance. So if the diameter is all the way across the circle, the radius is any point on the circle from the center point outwards. And so again, just to stress the importance of this diagram and what it means, is that for any circle, your diameter is essentially 2 times the length of your radius. If I have one radius and two radiuses, or the length of a radius multiplied by 2, it would give me the length of my diameter. So the diameter is 2 times the length of your radius, and essentially the radius is 1/2 the length of your diameter, because we know that the diameter goes all the way across, yet the radius is only from the center point outward. And we're going to start doing some equations with figuring out radius and diameter, but this is just a nice visual representation of how we get those numbers. So just to kind of put into practice what we just talked about, I've just redrawn our circle with a representation of what a diameter would be, which is your line segment right across the center point of a circle, and your radius, which is from the center point out to the edge of the circle. So I'm just going to kind of reiterate what I just said, but write it down this time. So in this lesson, you're going to come across questions where you're going to need to be figuring out the radius and diameter of circles. So like we said, if you are looking for or asked to find the radius, so I'm just going to represent that by the letter R, of a circle, and you have the diameter of the circle, the formula to figure that out would be the radius equals the diameter divided by 2. Or we can rewrite that as radius equals d over 2. Same thing, right? And we know that this is true because our radius is half of the length of our diameter. So we just need to divide this diameter length by 2, and that will give us the length of our radius. And the same thing is kind of true of just the opposite of that. If I'm asked to solve for the diameter and I have the radius, so I want to know what does the diameter equal, and I'm just going to represent that with a d, I just need to multiply my radius by 2, because we know that our radius is half the length, so if I multiply by 2, it will give me the full length. So these are the two kind of important formulas, shall we call it, for figuring out radius and diameter. Let's just do one example together before we go. So let's say I come across a question and it asks me, there's a picture of a circle, and it gives me a radius of, let's say, 5 centimeters. And it asks me what the diameter of that circle is. So I'm going to look back to these two formulas, if I can't do it in my head. And I'm going to look, and I want to know what the diameter is. So I'm solving for diameter, so I need to use this formula. I'm not solving for radius, because I already know what that is. So I'm solving for diameter, so this is the formula that I need to use. And I'm just, again, like we've done in previous units, I'm just plugging the numbers I have into that equation. Do I have what the diameter is? No, so we're going to keep that as our variable. And then we're going to go 2 multiplied by our radius, which we have, which is 5. And then we just carry out the steps like we've done. If there's multiple steps, which might get a little more complex in previous lessons, next lessons, not previous ones, you would use the order of operations. But this is a pretty straightforward one, step 1. The diameter equals 2 multiplied by 5, so the diameter is 10 centimeters of that circle, which makes sense because we know that the radius is twice the length. If half of it is 5, the other half will be 5, so the total length will be 10. Just on the other hand, let's just do one more kind of example with this same circle. If I have a diameter, let's say of 14 centimeters, and I'm asked to find the radius, we're going to pretend that this is a different circle because that wouldn't make sense. So if I had a diameter of 14 centimeters and I'm asked to find the radius, again, what formula am I going to use? I'm not going to use this one because I know what the diameter is. I'm going to use this one because I'm looking for the radius. So again, we're just going to plug in what we know. We don't know what the radius is, so we're just leaving that as a variable. I know that my diameter is 14 divided by 2, so I just need to do that simple problem there. 14 divided by 2 is 7, so our radius is 7 centimeters. So that's how you use those two formulas to find radius and diameter, and I hope you just understand the relationship between the two. I also just want to note before I kind of end this is that in this unit you'll be using your geometry set a little bit. You'll probably need a compass because you're going to be asked to construct perfect circles with certain radii or diameters, and a compass would really come in handy when doing that. And I'll do a mini lesson in class on how to use a compass if you're unsure or never used one before. So I'm going to leave it there for today. If you have any questions, come to class with those, and let me know if you have any issues.